The setup shown here is used for testing head-end units in the field of GNSS and for the parallel simulation of radio signals, interferers and RF recordings. In the GNSS simulation software, the different GNSS signals can be selected both in the upper and lower frequency band, which are distributed to the physical RF outputs. Furthermore, the noise simulation can be configured. In addition to the general settings, other settings such as simulation time with start and end time can also be set. This setting can be stated in the past or future. The other tabs are satellite times, clock models and atmosphere simulations. In the receiver settings, one or more receivers can be defined, whereby the receivers can have a fixed position or trajectory. Two modes are possible: case-based and real-time mode. If the IZT GUI of the signal generator started, the real-time simulation can be started directly afterwards. As soon as the simulation is running, you can see a world map with the simulated satellites and the receiver position in green. More information about the satellites can be found in the IZT GUI. The output spectrum can also be visualized. Since the signals are hidden under the noise, it can be switched on and off. In the GNSS simulation software, the sky plot and the signal strength of the simulated satellites can also be displayed live. The setup can be used to test various applications. The first application shows the testing of the DAB head-end unit with GNSS. For this, a DAB signal is configured in the IZT GUI before starting the GNSS simulation. In the spectrum, you can see that the GNSS signal is simulated on RF1 and the DAB signal on RF2. During runtime, DAB parameters such as power level and frequency can be adjusted. Interferers can be inserted and manipulated to test the GNSS receiver stability. The interferers can be freely selected. CB tones, hoppers, RF recordings and modulated signals. Up to 8 can be set. To test the DAB head-end units, RF recordings can also be played. For example, these may have been obtained with the IZT R3301 recorder. In this case, it is a DAB frequency band with 3 ensembles. White noise, through power density and bandwidth, can be used to adjust receiver sensitivity for testing. As an alternative to the stationary GNSS case, virtual test drives can also be simulated. This can be combined with all the applications shown before. The test course can be loaded via KLM file or NMEA. Live interfaces are possible via third-party software. the hardware is used for the setup, an IZT S1000 GNSS with memory extension. The software used is the IZT S1000 GUI and a GNSS Constellation Simulator software. In addition, a GNSS receiver is connected to a separate laptop.